Gentlemen, welcome. And what I hope to do today is just cover some of the basic principles of the changes, or as Chris referred to, the evolution of the 1 Series. And just to give you an insight of why these changes have occurred and what brought them about was that this device was developed 15 years ago, actually maybe 16 years ago now. The core of the electronics were built around a basically an EEPROM chip, and as everyone knows, technology has cantilevered over that that technology of the EEPROM chip, and we're now into the A6 technology chips, which has a tremendous amount of driving power. It's compact, it's small. And so the one key factor to remember when you talk about the 1 Series, the blue product, and the 1 Series safety transmitter is that you could almost refer to this thing as a supercomputer. When I initially started looking at some of the changes that our PhDs were engineering into this A6 chip, from my thinking perspective, I thought, well, this is a pretty simple task. But it turns out to be a major project, not a minor, and the changes that go into this product are quite intense. And it was referred to by some very smart people to me as a supercomputer. We think about a process transmitter, and you think of a process transmitter as this thing is processing immense amount of data. And you can take any manufacturer of a process transmitter and use this analogy to it. It's processing immense amount of data. And when I took that scenario to our designers, and I said, well, how do you look at our blue product, and in fact our yellow product, our safety transmitter, a set safety transmitter, and then our 1 Series product, and compare it to a process transmitter? How do you compare the amount of data that we process versus what they process? And these fellows in their very calm intellect looked at me and said, you silly guy, probably 10 times more. I said, how can that be? We're not a process transmitter. But their response back to me was, this product wasn't designed to be a process transmitter. It was designed to be a smart switch that has an immense amount of intellect to process faults. And the whole idea is to have a product that's smart, that tells you if it's working or if it's not working, and yet at the same time have the ability to switch or do other things. And so what we're going to do is we'll talk about, keeping that in the back of your head, we'll talk about what the new platform looks like, what it means to you, where you can take this thing, and I think you'll see a lot of value once we start peeling this onion skin apart on this new technology. Now, everyone's aware that the 2W, the square box, has gone away. The sale of that product started to fall off in the popularity of the explosion proof, if you would, that almost that 120 series looking enclosure surpassed the other design, and therefore what we ended up with is a product that would basically become the same price as the explosion proof device. So it was ruled that having that complexity in the product line and supporting it wasn't worth the dollars people would pay for it, so we eliminated the square box. Now the only availability in the 1 Series is this design that you're looking at in the screen in a Class 1 Div 1 configuration. So the whole idea, as I talked about, is the fact that we wanted to increase the reliability and capability of some end users, that we could introduce this product, but at the same time not increase their cost. So the core dilemma that we continue to see, and as I have been traveling across the country fulfilling my role as Director of Functional Safety Technologies, are really somewhat interesting. You know, you want to upgrade, and you need to upgrade your mechanical switches to a state-of-the-art technology. And in many cases, you would think that would be a process transmitter. And the idea behind that that improvement is that you improve, of course, reliability, and that's a fact. You reduce the maintenance expense on a mechanical device by going to an electronic device. It improves the process data that you can receive out of a device, and of course, reduce downtime. And so that's one of the dilemmas that the industry faces. Up until now, the cost to accomplish this has been pretty high. If you're going to go to a process transmitter, you're going to go to a price well over $1,000, and we know in most cases it's anywhere between $1,300 to $2,000 just for the device itself. So that is you know, that weighs pretty heavy on a lot of process plant budgets today. We know what the economy is doing to these budgets, and so it makes it tough to do. And what are the choices? In many cases, we're still, and I still feel after 15 years, we're still out introducing this product to a lot of people that haven't seen it. And so we, in my opinion, we still have a lot of opportunity to grow the revenue for this product, and then also save budgets across the industry. So what choice do most people have? And that is, we just covered it, and that's to stay with status quo. And I don't know about you, but I like to challenge status quo often, and I do. And I think that we live in a day and a time with budgets we have to. Our job is to show how to do that and how to accomplish that as it relates to this whole scenario with the transmitter. Status quo in the past has been just basically disconnect and remove the old switch and go ahead and install the process transmitter in its place, drill new holes. It's about 3 times the price. And we have to remove the existing power wire. We can't install a transmitter with a power wiring, so we have to install new signal wiring and conduit and such back to the control cabinet. And then the next piece of the puzzle is we've got to remove the existing discrete I/O and spend quite a bit of money and install analog. And then the next piece of the puzzle is somebody's got to program this thing. They've got to write a ladder logic to get this thing up and running. So you kind of feeling the pain and the cost associated with with this scenario. It takes a lot of time. It takes a lot of cost. And there's the pain element of it, and that's the piece of the puzzle that I think most technicians recognize. Sometimes they just don't feel the impact of the pain until they get into the calendar and their calculator and they see what they're up against. But from my position, I like to break the status quo, and I like to promote the fact that it can be done in 3 very simple steps. The first piece of that puzzle is remove the old switch. Whether it's a Ashcroft switch, a static O-ring switch, and I would even contend if it's a 120, take the 120 out, and with the same platform, the same footprint, we could solve a problem fairly quickly. So again, disconnect the switch, install the new 1 series electronic switch, and in this case we're going to use the existing wiring, we're going to use the existing I/O and the existing PLC program, the ladder logic. It's all the same infrastructure. Nothing has to be changed other than we're going to a new device that has no moving parts in it. Wire it up, program the set point locally, and you're done. And this is a major cost savings that we can promote throughout the industry to bring value to the technology that we have available in the new 1 series. So how can we do that? Well, we have really a good story to tell, I think, an exciting story to tell, and that is that our device is still patented. We still own the patent on it, on the two-wire technology, and this is something that that we could talk about because no one else can do it. Competition is not out there. The way that this technology works has not changed much at this point from the old technology of the 1 Series. And just to review it, it's fairly simple. And that is that it powers itself using residual current from the PLC or the host, no matter what that host is. It could be a solenoid valve, it could be an interposing relay. There's always that leakage current less than 480 microamps available that we use to power the 1 Series. No batteries, no solar, nothing else needed to get this done. The output is programmed to open or close just like a mechanical switch, but it's done at the keypad as opposed to an external source like a wrench and nitrogen and a test gauge to accomplish that. It works with basically all major brands of PLCs, DCS SCADAs, RTU packages, interposing relays, solenoid valves. The key factor that you have to pay attention to is the minimum voltage requirements when you're starting to switch interposing relays and solenoid valves. But as far as any other major brand of a PLC, DCS, SCADA, RTU, we work fine. We have a great handoff as it relates to those minimum load requirements. And we could switch various loads. I'm going to talk about those various loads that we're able to switch. That has changed from the past. We've basically gone from 8 models of the 1 Series to 3, and that makes it quite a bit easier when it comes to selecting devices to be used. We'll talk about some of the benefits. We've already talked about how this device switches, how it works, the patented 2-wire technology, that secret sauce that exists in this product. But here are some of the key benefits that you get out of this device as opposed to a mechanical switch. And whether or not people say they use switches or not, by the way, I am pleased to tell you that we still make 44,000 120 series a year. So the business hasn't shrunk necessarily, but it hasn't grown. It's steady. 44,000 switches a year of the 120 series for the past 85 years is a major infrastructure across the world. And we could replace a lot of that with this 1 Series product. It fits right in the same footprint. So the key, some of the key benefits here is that this has a fully adjustable deadband, this switch does, as opposed to a mechanical switch, which you live with what you get. So from the face, you can program your set point, and you can also program in your deadband from 0 to full scale. You make that adjustment. That's up to you. It's gauge. It has a local display on it, and this local display is what we use to program the device, read the process variable on this device, and then also it gives us some data back as far as the health of the device and also the capability to interrogate where the device is seeing minimum and maximum extremes. So it's all done from the front end of the display that you're looking at right now. Now, for a peace of mind, of course, this device is self-diagnostic. It has a patented I am working capability that tells you quite a bit. It gives you some key interfaces between its health, so you can monitor the process sensor to determine if that sensor becomes plugged or not. You can also monitor all of the electronic functions of the device, and locally it will tell you if the product is working, if it is not working, if it's been overpressured or underpressured. It gives you codes across the front so you can diagnose those circumstances and basically take corrective action as it would be. In a lot of cases, there's a lot of discussion about proof testing on mechanical and electronic devices, including transmitters. And it has been determined in a lot of proven in use scenarios that the 1 Series with its self-diagnostic capabilities needs less proof testing than mechanical devices, and in fact some transmitters, because it tells you its health. That health can be also remotely located back to your PLC or your DCS as a human interface, an HMI. So now the operators even know the health of this device as it is out in the field. And of course, I talked a little bit about the plug port capability that this product has as well. So we have, if you have specific needs outside of what I've covered, and a lot of companies do, and you guys hear it often, is, well, wait a minute, that's all nice, but what about heart? Does it have heart? And that question has been asked of this device for the past 15 years. And up to now, the answer's been, no, it doesn't. It's all programmed from the face of the device. We still have that capability in our basic unit. So we'll talk a little bit about how we're going to address that heart scenario here in just a moment. Again, just real quick, if you're going to compare against electronic to mechanical, here are some of the benefits of the 1 Series over the mechanical switch. So all electronic, no moving parts, it's self-diagnostic, it's got the digital display, 100% programmable, including the deadband. It's a switch, it's a gauge, it's a transmitter. And the accuracy is, and repeatability, accuracy is 0.5%, repeatability is 0.1%. And so this is pretty simple. You guys have been around these products for quite some time. You know the difference, but here you can see the value side by side, and the cost is pretty comparable today to a mechanical switch. So the question has come about repeatedly, what about heart? What about heart? And it is with great pleasure that I announce to you folks, as of today, heart is now in the 1 Series product. So the 3 models that exist today of the 1 Series basically look like what you see on your screen. The very first product is a 1X, and nomenclatures have changed also, but the 1X SWLL is primarily just a switch. It is what the 1 Series platform was designed to do, and it was based on just this this simple switching using the leakage current to power the device. It still exists. It's a 2-wire device, and its power capability is 7.8 to 50 volts DC, and that's a discrete input capability. It has basically a switch rating of 7.8 to 50 volt DC at 1/10 of an amp. It's a MOSFET output, and I want to point out that this voltage capability has changed on the MOSFET to the previous units. The previous unit was switching anywhere between 24 and 40 volts DC. So what we did was we expanded that threshold on the MOSFET to this 7.8 to 50 volt DC at 1/10 of an amp. What that allowed us to do is talk to or switch more of the quite a few more solenoid valves that were out on the market today, and then also quite a few of the interposing relays that we were interfacing. Now there's a minimum load scenario that is always important to pay attention to, and that is this minimum load requirement of 2.0 milliamp. So again, it simplified the whole capability of this device. That first device is anything that's going to be interfaced with a PLC or DCS, and all you want to do is switch to a discrete I/O. That's your product. That will get it done. It's the same two wires that mechanical switch was connected to. Take those two wires off, put this in, wire them up to the terminal block, and it's up and running. So it is also, keep in mind, still an optically isolated device. Again, it's going to work just like the switch did. Now, we've improved our capabilities now by offering HART. So the next device that you see on this spreadsheet is basically the 1X TX SW. And what that is basically is the same device that we saw above, but now this device has two switches in it. You remember before you would have thought of it as the 8W. The 8W is gone. It's the 1XTX SW. What this is, it is a loop-powered two-wire transmitter. It's a 4 to 20 milliamp transmitter. It has or houses two switches, switch 1 and switch 2. If you don't want to use the switches, we'll talk about that, but if you want to just use one switch, use one switch. You want to use both switches for high-high, high-low capabilities, it's in here. The rating on the switches are 0 to 280 volt AC or DC. So as before, you had to be very specific on the voltage capability. We now cover AC and DC, and it is at 0.3 of an amp. So still, again, a MOSFET output, but you have some switching capability in here. And you'll see that the load switch ratings on this device basically are 0 to 30 volt DC internally at, and again, that's a MOSFET output. So you got two switches in there, and they can both have, you know, separable settings in them. And you could change the dead bands in them. You can do whatever you need to do with this. But the cool thing is that this now is a HART version 7 capable device. What that means is that you can walk up to this with your Merriam HART calibrator, or there's a P&F computer-enabled calibrator that you could use to plug into the 1 series, and it can now be programmed via HART, including the settings of these switches, the deadbands of the switches, including the fact whether or not you want to use a latching relay or non-latching relays, the plug port technology. All of these things now can be done from a HART handheld or a desktop calibrator, including the fact if you would want to set up DDs into this 1 series with the enabled HART, it can also be done as well. So if you want to put in a if you want to put in a serial number, or you want to name this device, you can do it, and the DDs will then report back its address, so to speak. So that's the 1X TX SW. And then the next, or the last piece of the puzzle to this technology now is the 1X TX00. And if you look at that, it's pretty self-explanatory. This is just a transmitter with HART. It has no switching capability. It's a loop-powered 4 to 20 milliamp device, HART enabled. So once again, you could go into this thing just like a transmitter. You can, it does not have a 10 to 1 turn down, it's just got a 2 to 1 turn down, trying to keep the cost in check. So it's a 2 to 1 turn down capability. Through HART, you can set your DDs, you can put an address into this thing. and it also, again, has diagnostic capabilities. So, you know, plug port is in there, and all your IAW scenarios are in there as well. So heart is here. We have it. And those are the three models as they exist currently. The one thing I want to remind you guys too, that we're seeing quite a bit of, as I travel across the country, I'm seeing the requirements for dual seal really predominant today. Canada, you can't sell anything into Canada today without a dual seal. This whole dual seal scenario is really comes from the mandate from NFPA and the National Electric Code to contain flammable or combustible materials and then vent them to atmosphere so that they don't make their way into the enclosure and then down to the control room via conduit or a raceway. The real selling value to UE's MO41 option is the fact that this device was designed specifically to meet the dual seal ratings and the dual seal certification criteria through NFPA and NEC. This design of this product is that it is the standard welded 316 stainless steel sensor. Should that diaphragm be compromised, you then would get leakage into the intermediate chamber, which would then go out to atmosphere or could be scrubbed, and then there is a glass to metal header to keep that leakage out of, or that compromise out of the enclosure. This device, this MO41, has been certified by UL to be used as a dual seal device. So when you're talking to a customer and they may be trying to come up with their own gyration of this dual seal application, which they do, you can then basically use the selling pitch that this thing is UL to the intended use when it's put onto our device. So neat selling point. We're selling quite a few dual seals right now. So the pressure sensors haven't changed. There is a compound range. I want to remind you guys that this is overlooked. It will be front and center in our new bulletin, which is coming out next week. It is you know, negative 4.7 to 30 and negative 14.7 to 100. So the compound range is available. We have 11 positive gauge pressure sensors going all the way from 5 psig to 6,000 psig. And remember that all the calibration units across the board can be selected in the 1 series. So whether or not you want water column range, you want you know, PSI, English, or any metric ranges, you can put those in yourself in the field. Those can be changed as they install. So the skid guys really like this product based on where it's going to be sold, and it has all the agency approvals across the board from CUL, UL, ATEX, GOSC. It has everything you're going to need to cover all the international approvals. And then we have 4 differential pressure sensors as well available in this thing. Temperature, these are either local mounted RTDs, the remote mount RTDs as well. They are RTDs, and simply for the fact that this is self-diagnostic, and we can detect should an RTD fail and get that announced back to the HMI quickly. Thermal wells, any type of configuration to make this thing work, we can also make that happen. So really where we are right now in this whole family of the 1 series, this really rounds out the capability of the Blue product, from static pressure differential to temperature, from just standalone as a switch, standalone as a heart-enabled transmitter, or HART-enabled transmitter plus 2 switches. We have that capability in this enclosure. And then, of course, we round it out with the ever-increasing popularity of our SIL 2 certified, SIL 3 capable safety transmitter. And we can talk about that with your questions if you have any. But that product is doing very well for us. I just want to throw out a couple places that we've been successful, some markets we've been successful. Should you be looking for some ideas of where to take the 1 Series and the safety transmitter. This is the Blue Plains project out in Washington, D.C. If you're not familiar with it, it's probably the largest #1 greenfield project for wastewater management going on in the country. This entire device, or this entire facility, has over 850 of the 1 Series installed throughout it, and those are all mounted on top of isolation rings. We've done very well at this facility. It was engineered out of Columbus, Ohio, and it's one of the success stories we have for the 1 Series. New Orleans is another location for us. We were called by some of the developers in the A&Es in the New Orleans area that were rocked by floods several years ago. So we came in. One of the problems they were having was keeping these pumps up and running, and the mechanical switches, the redundancy needed, the SIL capability on these pumps, and we were able to install 1 Series along with some mechanical switches and safety transmitters to keep the integrity of these pumps up and running in worst case scenarios. We do very well in the power industry with the 1 Series, probably one of our marquee areas for this product. GE standardizes on the 1 Series on all their seal oil skids. So you'll see us predominantly in power. We do very well there. The 1 Series has also been very popular in replacing a lot of the Honeywell mechanical switches in the boiler area. Here's one example of an OEM, Dillon Boiler, who uses now the 1 Series, and of course now with a lot of the NFPA requirements on SIL 2 and SIL 3 capable applications, the 1 Series has taken off in the boiler applications now too. Transportation, we used to be back in the day with the E55s, you couldn't see a refrigerator truck going down the road without an E55 on it. It was a very big market for UE, but it's become, again, the transportation market with the 1 Series has been a very strong market for us. So, you can see basically that these applications are predominantly all over the place, even in the automotive industry, with a lot of the hydraulics. Honda manufacturing has pulled out all of their square D switches and replaced it with this technology because of the fact that it's, first of all, it's a drop-in replacement, and second of all of the diagnostic capabilities that come out of this device allow them to identify hazards or identify failures quickly and rectify them by replacing the switch or taking whatever action they need to take. So this is just another shot of that Honda scenario. Those are all hydraulic lines. If you're not familiar with Reliance Industries out of India, Reliance actually happens to be, I think, one of the largest users of Rosemont transmitters in the world. And so they have embraced the 1 Series because of its economical replacement to switches and its reliability as well with the IM working. So there's in Reliance Industries, we're well over 1,000 various models sold within Reliance. In fact, they actually, if you go to the internet and to YouTube, and I'll send you a link to this, one of the engineers from Reliance gave his dissertation for his PhD on the value of installing 1 Series technology. So it's really kind of interesting to listen to. I'll send you the link. Petrom in Brazil also has migrated over to the 1 Series technology. Formosa in Taiwan. This just gives you kind of also that international flavor of how powerful United Electric is globally, not just in the U.S. And then, of course, just really a snapshot of a lot of those people that we're currently doing business with the 1 Series technology.